All right, here's part 3 in finding the whole given the percent and part. So remember, in the first two, we found the part, we found the percent, and now we're going to find the whole of everything. There isn't much real world examples on why you would be given the percent and the part and then be given the whole, but again, it works the same exact way. So we're going to go through 4 examples again, practicing putting all the pieces in where they belong so we can find the whole. All right, so again, let's refer back to our manila color box over here. Is over of equals percent over 100. So again, we're going to be piecing all the pieces to where they belong and solving for each proportion. Okay, so let's go ahead and start with placing our is of percent and 100. You guys should be experts at this by now. All right, so let's look at this. 12 is 20% of what number? Okay, so I know 12 is. 12 is, it says right here, 12 is. So let's go ahead and place the 12 where it belongs. 20% of. Now, some of us are going, well, if the is comes after the 12, then the of must be the 20%. No, remember, percents are percents no matter what word is next to them. So the 20% is going to go where the P is. So 20% goes right here. All right. So 20% out of 100 is 12 out of how many? Some of us can see the relationship on what's happening from here to here. We know that 20 times 5 makes 100. So 12 times 5 makes 60. So again, if you cannot see that relationship, we can go back to our cross multiplication. So again, let's look at the two numbers that are diagonal from each other, 12 and 100. And we're going to multiply 12 times 100 and divide it by 20. And that gives us a grand total of 60. So 12 is 20% of what number? The only thing I can think of is my M&M's example. I have 12 red M&Ms. They need to be 20% of all my M&Ms. So how many M&Ms am I going to need all together? So if I want to use that as my real world example, that would be an example for that. All right, let's go on to example 2. 15 is 60% of what number? All right, so let's go ahead and put is of percent 100. Okay, let's start decoding this. All right, 15 is. So I know what my is going to be. It's 15. 15 is 60% of what number? Again, just because the of is kind of attached to that 60%, percents are percents no matter what. So that 60% stands alone. So 60%. All right, so our of what number is what we need to find. Whoops. Let's go ahead and use the eraser tool. So let's find what number. All right, so again, some of us can see that 15 times 4 makes 60. So if I think what times 4 makes 100, I could do some quick mental math. And again, if we don't see that, no problem. We've got our trusty cross multiplication, our little best friend's trick to do the job. So again, we're going to multiply the two that are diagonal, and we're going to divide by 60. So 15 times 100, ooh, really weird 100, divided by 60 gives us 25. All right. So again, if I want to use my little M&M strip and say I need 15 blue M&Ms and they need to be 60% of my total, how many M&Ms am I going to need? I'm going to need 25 because that's what 60% of 25 is. It's 15. All right. So it's 15. It's 25 M&Ms is altogether is going to be our answer. All right. Now I've done two where they've been worded that way. Now I've got the numbers and the words mixed around, but that's okay. We're still going to use our decoding skills to figure it out. So again, we put our is over of and our percent out of 100, and let's start decoding this. All right, 30% of what number is 150? So I have 30%. That's my percent. So let's go ahead and change that guy out. 30% stands alone. All right, of what number? We don't know. Is 150. So our is 150. 150. So our variable is our unknown number. Let's use n again. All right. So in this one, again, we could use some mental math or we could use our cross multiplication. Let's go ahead and use our cross multiplication. So which two numbers am I going to multiply? The ones that are diagonal, which are 150 and 100. So if I do 150 times 100 divided by 30, I am going to get 500. So 500 is my answer. 30% of 500 is 150. Okay, because 30% is part and 30% is 150. Okay, and 150 is less than half of 500 and 30% is less than half of 50. So use some tricks to know if we got our answers right or not. All right, going on to our last example. In a sixth grade class at CWMS, 40% of each class has 10 girls. What is the total number of students in each sixth grade class? I'd say this is pretty accurate. If we were in school, we could actually look and see if this works. All right, so again, it's a word problem. Some of us are already having some anxiety over it, but have no fear. Let's decode this and make sure we can get it all worked in our pieces. Okay, in a sixth grade class at CWS, 40%. Bam, there's our percent. So let's go ahead and replace P with our 40%. 40%. Again, there's that of right next to it, but percents are percents no matter what. We don't put it in for our of. Okay, of each class has 10 girls. So does the of go with the 10? Let's keep reading. What is the total number of students? All right, so what is the total number of students? Well, total number of students. I have the word is and of in there, but I want to know what the grand total is. And aren't totals out of 100 all the time? So that means my of is what I don't know. I don't know my total number of students. I just know how many girls there are. So that's going to be my unknown, the total number of students. Okay, so that means that in each class, there are 10 girls. There are 10 girls. Or we could say there is 10 girls. There is 10 girls. So again, I have a proportion all set up, ready to go. And now I know that I can cross multiply and divide if I need to, or I can look and say, 10 times what makes 40, and then what times 4, 4 makes 100, because 10 times 4 makes 100. But again, if we can't see that, let's cross multiply them again and divide them. So we have 10 times 100 divided by 40. And that gives us 25 students in the class. There are 25 students in the class, 40% are girls, and that would be 10 girls per class. All right, I hope you understand how to find all pieces, percent, part, and whole using our proportion problems.